Hello everyone, it is nice to be here with you again. Today we want to break down and understand projectile motions as best as possible. We're going to focus on projectiles that have been launched from the ground. To understand this, we're going to look at a practical example of a golf ball being hit from the ground. Once the ball is leaving the ground, it will leave at an angle. At this initial point, just before the ball is being hit, there is no motion. However, the ball will eventually move through the trajectory to a maximum height. Then it will fall to its final destination. We're going to look at these three motions or positions to explain the motions of projectiles. Now, before I go into the assumptions that we need to make, the first thing I want to point out is that the motion of a projectile is parabolic. Also, there are two independent motions. One is the horizontal and the other is the vertical motion. They are occurring at the same time, but they are independent of each other. Now, our first assumption is that the ground is flat or level. The reason for this assumption is that the height for the maximum point to the height for the fall is the same. So the height for rising and the height for falling, they are the same. So the next assumption is that the horizontal velocity is constant. And since the horizontal velocity is constant, there is no acceleration in the horizontal path. The next assumption is that the vertical velocity is constantly changing, and this is the velocity in the y component. Since the velocity is changing, then we can note that there is an acceleration, because acceleration is a change of velocity over time. Now, the other assumption is that the only force is acting is that of gravity. And again, gravity acts only in the vertical position. And once we have gravitational force, then we will have an acceleration. And from this, we know that the force or the weight of the object equals to the mass times the acceleration. The final assumption is that time is the same. So time for the x component, which is the horizontal, and time for the y component, which is the vertical component, is the same. And this is simply because it is the same object that is moving. So it moves in the same time. Now, let's now go into the different positions to understand exactly what is happening, or to describe the properties of the motion. So at the initial position, when the ball is on the ground, there is absolutely no movement. So at this point, the ball is at rest. Now, what is also important to note is that there is a velocity when the ball starts to move. So the ball will move from the ground with a velocity. We're going to assume that this is 20 meters per second. We're not going to use any numbers for calculation today. I will do an example with the numbers. Also, again, remember that the ball will leave the ground at an angle, and we're going to assume that this angle at this time is 30 degrees. I will use an example with the numbers after this lesson. Now, the next thing to note is that the distance in the y component vertically, there's no movement. So therefore, there's zero distance. The distance in the x component, which is the horizontal position, is also zero since the ball is not moving. Now, the initial velocity in the y component is given as sine theta times v. Remember, v is this velocity that the ball actually start moving with. And in this case, we're using 20 meters per second. Now, the initial velocity in the x component is given as cos theta times v, which is cos the angle times v, which in this case will be 20 meters per second. Now, once the ball starts to move, it will eventually reach its maximum height. And this maximum height is from the ground. So the things that we need to know right here is, one, is that the initial velocity in the y component coming from its original point or position is given as sine theta times v. So this remains the same because it's the same object that is moving from its initial position. However, at this point, we can say that the ball is momentarily at rest, which means it is not moving for a very brief moment. Hence, the final velocity in the y component at this point is given as 0 meters per second. Also, what you need to remember is that since the ball is going up, it is going against gravity, so the acceleration is minus 9.8 meters per second squared. In some examination, they will say use 10 meters per second squared, so it doesn't matter what value is given. Just remember that since it's going up, it is negative acceleration. Now, to find the time at this point, we can say time is given as the final velocity, which is VFY, minus the initial velocity, which is sine theta times v, which is the 20 meters per second, divided by minus a. Now, this expression came from this formula to say the final velocity equals to the initial velocity plus minus acceleration times t, which is time. So once you make t be the subject of a formula, then it will be the final velocity minus initial velocity divided by minus acceleration. Now let's now consider the height. But before I go to the height, let me point out something real quick. The time that we found right here, it is just the time for the maximum height. The time the ball takes from its initial position to reach the maximum height. That's what we just expressed. I'm pointing this out because I will show you another time, which is called the time of flight. So this is the time of height. All right, and we want to make a clear distinction between both. Now, the maximum height can be given as dy, or you can just say y, or I can just say distance in the vertical component or distance in the y component. Now, this distance is given as ut plus half minus at squared. Again, the initial velocity here will be given as VIY, which is the sine theta times V. And you use the time that you have calculated here and the minus 9.8 as A. Now, once you have found that, we can actually look at different properties of the projectile now by looking at the final point when the ball falls to that final destination. Now, there are some things to consider here. One is that since the velocity in the horizontal component is constant, then we can express the final velocity of x equals to the initial velocity of x. Now, the next thing we need to point out is that at this point, since the ball is on the ground, the distance in the y is 0 meters. There's no height. So there's no distance in the y component. The next thing is that t is given as final velocity in the y minus the initial velocity divided by minus a multiplied by 2. Where this comes from is that at this point where v minus u divided by minus a is at the maximum height. Now the assumption is that at this maximum height, the ball is halfway its journey. So therefore, the time to reach halfway its journey, which is the maximum height, which is this t, and given us this expression, for the ball to reach to its final destination, it will be twice that time. So therefore, the time that you have calculated for the height must be twice when it falls. Okay, so if you look at the parabolic halfway to its final position, the time to do that must be multiplied by 2. Another way to do this, we can say since the distance in the y is 0, we can say then 0 equals to ut plus half minus a t squared. Now, this will be the time for the entire flight. So, any of these two expressions can be used to calculate the time for the flight. So, here I want to make the distinction again, is that the time for height and the time for flight. The time for flight is twice that as the time to reach the maximum height. Now, once you have calculated the time, we can go ahead and now figure out the final expression for this time, which is given as the initial velocity in the y, which is u, divided by half of minus a. So you can just remember this formula, that the time for the flight is given as the initial velocity in the y divided by half of minus a. That's a very simple equation to remember. Now we can use this time to calculate our range. So the range will be from the starting point to its final destination. Now remember that the velocity in the horizontal component is the same. It remains constant. So therefore we can say the distance in the horizontal component or along x is given as the velocity in the x component multiplied by t. This velocity could be the final or initial, doesn't matter, because both are the same. All right, so you can use these 3 points and the formulas given to calculate different variables of a projectile. All right, so at this point, we're going to close, and I want to tell you that I appreciate you watching this lesson. And also, please remember that your trajectory determines your destiny. Have a wonderful day.